and welcome to New Voices in AI, the series from AIhub, where we speak to PhD students, early career researchers, and those with a new perspective on AI. I am Jo Daly, and this week I am speaking to Dimitri Coelho Mollo about some of his work. And without any further ado, let's begin. First of all, thank you so much for joining us today. Could you introduce yourself, tell us sort of where you are, who you are?
Right, of course. So yeah, thanks for having me. I'm Dimitri Coelho Mollo. I'm a assistant professor for or in philosophy of AI at Umeå University in Sweden. And I work on philosophy of cognitive science, philosophy of AI, some philosophy of mind, some philosophy of biology. So I have a pretty wide range of interests.
It's a pretty wide range, yeah. Maybe could you possibly like expand a little bit more? So sort of a lot of philosophy, a lot of things happening there. Could you maybe expand a little bit on what you're kind of working on currently?
Right, of course. So I think the shortest way to see the kind of thing I do is in terms of a philosophy of science, right? So it can be a philosophy of science and try to figure out from one side how science works, but also try to figure out, well, given a certain problem that exists in science, um, how can we perhaps solve it or help solve it conceptually or theoretically? And I do a little bit of both. Directed though, so targeted at especially AI and cognitive science. So my questions, the questions I work on are like, what are the foundational notions, the basic notions in cognitive science, in AI? What role are they playing in the sciences? How can we, better explain them? How can we try perhaps to come up with better ways of understanding them so that, we can make progress in AI and cognitive science? So like to give a more concrete example, so both in AI and cognitive science, people talk a lot about computation, right? So computational processes and computational models and so on. But of course, well, what is meant by computation, right? So how can we make sense of the notion of computation in these fields of research? So this is one of the questions that I have worked on in the past, and also representation, intelligence. So all these, basic concepts that people throw around, but often, don't pay too much attention to. These are the kinds of things that I'm most interested in.
So when you describe something as being like foundational, it's kind of those like they say basic concepts, but it's like what I imagine like what does this kind of mean? Kind of breaking it down into its kind of I guess smallest parts. Or
Right. And also, I mean, not necessarily just, looking at how people use it and just trying to make sense of it, but more, I mean, because people use concepts and sometimes they don't, fully grasp. They just, pick them up from, the practices in science and philosophy. So it's not just, descriptive. It's also a matter of figuring out, well, given this particular scientific project, let's say explaining, how a certain cognitive process works.
mm,
And we see that explanations are given in terms of certain computations being performed by a certain part of the brain, right? And then we try to figure out, well, how can we describe those processes? Is, using the term computation useful? Is it not useful? Does it lead to confusion? Are there better ways of understanding what's going on? And the same, of course, applies to intelligence, right? So when we talk about intelligence, both in humans, in non-human animals,
mm,
and in potential artificial systems, well, what do we mean by that? So what do we require something to do, or to be able to perform, such that it counts as intelligent, right? So how can we say, well, are ravens intelligent, or is GPT-3 intelligent,
mm.
right? This large language model. So it's difficult to ask those questions and, get meaningful answers unless we first try to figure out, well, what is it exactly that we are trying to capture when we talk about intelligence?
Yeah. It's kind of interesting when you're saying about sort of comparing human intelligence, animal intelligence, and kind of AI intelligence. Sort of makes me wonder if there's kind of if that means different things for those different kind of domains as well.
Right. So that's a very good question, and it's kind of an open question. So there has been this tendency until, well, in many fields, not all, um, until recently, of seeing intelligence as something, of which we are the paradigms, right? So we are, the ground level of intelligence, and everything else is measured in comparison to us.
It's like we're the
Be
benchmark.
them, yeah, exactly. Like, what we do is the benchmark for intelligence. Um, if, other animals and AI systems don't, meet our capacities, then they are not intelligent, right? Or
Mm,
they are. And if you think even about, the kinds of capacities that until recently lots of AI was interested in,
mm,
it was those kinds of things that we humans tend to think are markers of intelligence, right? Playing Go, playing chess, proving mathematical theorems and
yeah.
stuff like that, right? While other things that we tend to think are, not intelligent, like just moving around and,
Mm.
being
Looking at
able to, yeah, picking up things or opening doors and so on and so forth, that we take not to be intelligent, then we ended up not giving much, importance to those things in designing AI systems or trying to measure their capacities. I mean, now this is changing, but it's an interesting way to see, more in the history of AI and cognitive science, how um, notions of intelligence started and still are, strongly shaped by our view of human intelligence that then we try to impose on other things. And I think that's problematic. So I think that, and part of my work has been dedicated to coming up with characterizations of intelligence that can unify what's going on in these different fields. Because as you pointed out, there is the risk that, what the comparative psychologist is talking about when they are talking about, what ravens are doing or what cockatoos are doing uh, as intelligent, is very different from what, a cognitive psychologist might be talking about when they talk about intelligence and talk about, IQ tests and stuff like that. So I think there is lots of variation on what is meant, and I think one important project is that of trying to unify, to find what is in common between those projects, because in the end they are trying to zero in into something, in some phenomenon in the world, that all these different systems, human, non-human, animal, non-human, and artificial, non-human, uh, uh, can be instances of. So trying to unify these fields is one of the things that I try to do, and I think it's very important then to have a notion of intelligence that can capture, at least to a large extent, what the comparative psychologist, the AI researcher, and the cognitive psychologist are interested in.
Really, really kind of fascinating, kind of overarching topic. Um, how did you kind of get into AI? Because there's kind of all these elements kind of being drawn in here. How did you get started?
Right. So I think to a certain extent, this uh, kind of approach in which, lots of things, you look at lots of things and try to bring them together, is maybe one of the, at least as I see it, one of the main roles of philosophy. So I think that's one of the main contributions that philosophy can make, is exactly to give, as you mentioned, this more, abstract, more general uh, uh, um, framework that, puts into relationship fields that may not communicate together and that may think they are doing different things, and then provide, some conceptual clarification, some unification, help with theoretical advances, and so on and so forth. So I was always interested in this, interdisciplinary view of philosophy since the beginning. But I actually started looking mostly on philosophy of perception. So trying to figure out, well, what's going on when we perceive the world? How can we make sense of the relationships between, what we experience and what's going on in the brain? How we can make sense of the fact that, we use the information we get from perception to then guide our behavior. So anyways, from there, I moved more and more towards philosophy of cognitive science. And then, I mean, philosophy of cognitive science and AI, I mean, cognitive science and AI more generally, are kind of sister disciplines, right? So they kind of were born together, especially at the beginning. There was lots of interaction between people doing AI and people doing cognitive science. They share lots of those foundational notions like computation, representation, and so on. So they are projects that share a lot, right? So scientific fields that share a lot. And I started getting more and more interested about, well, how and whether can AI shed light on, cognition and the other way around, right? And also one thing that I think is very interesting when it comes to AI is the fact that it opens up possibilities for cognition and intelligence that may be very unlike those that we see in biological organisms,
Mm.
right? So we are talking about systems that are very different from biological systems in many different ways. Um, so they may offer us, some answers about, well, which other possible solutions are there, this space of solutions to the kinds of things that we think require cognition, that require intelligence, and so on. So then, yeah, little by little, from perception, I moved to cognitive science, and then to AI, but always trying to keep all of that together, anyways.
Yeah, it's kind of, I think something that we've heard, I think, before in the series is people saying often there are fields that aren't things that you would immediately think of being linked to AI, things like art, but like similarly philosophy, like you say, there's quite a lot of overlap there in that kind of cognitive science kind of way of looking at it. There's definitely a lot that they can kind of learn from one another. It also makes
Yeah,
me.
and there are some debates or some questions now in AI that are actually philosophical questions, even very old ones. So lots of the discussion in AI right now is about, well, can we have systems that can do, intelligent stuff based only on what they learn from experience? Or do we need to have some sort of innate, set of representations or capacities where innate, of course, is hard coded
Yeah,
in the case of AIs or not? So this actually rehearses in a more, empirical flavor uh, discussions that have been going on in philosophy for centuries, right? Between, in this case, empiricists and rationalists. And similarly, discussions that have occupied and do occupy developmental psychologists. So, to what extent in humans, most of what the capacities we have come from just learning from experience, how much does it come from things that are there from the get-go, right? So these are all discussions that come from philosophy, and then take a life of their own in AI and related fields.
yeah. Um, I guess also is we've kind of talked a little bit about how you got into AI, um, and sort of I guess my next question is where do you see things kind of going in future, or where do you kind of hope that some of your research could be used in the future?
Right. Well, that's always a difficult question to ask to a philosopher, right? Because we are always working on a more um, abstract like bird's eye view level. I mean, not always, but many times. What I think my research can contribute is, for example, shedding light on, what we require for something to be able to do for it to count as intelligent, but also, and more concretely, being clearer about that also allows us to be clearer about which kinds of methods should we use in measuring and studying AI systems, right? So one thing that I'm working on right now is take these large language models, right? So GPT-3, PaLM, and so on and so forth. How can we understand what they are doing, right? Their outputs are very impressive. But in light of the outputs, what can we say about what's going on? Can we say that, the things the outputs they produce are, meaningful? Are they displaying some kind of reasoning capacity? Um, how can we try to figure out and test whether this is the case? And how can we even make sense of, what's going on there, right? Because these systems are very unlike anything else that we see in nature, right? So which concepts do we need? Which explanatory tools do we need to best make sense of what's going on in these cases that are quite novel and quite, unprecedented? So these are the things that I, try to help with. Of course, they are more at the theoretical level, but they can also have direct, consequences for more practical issues. For example, one thing that I've done that connects with this, I've done it with several colleagues, was to create a benchmark tapping into the capacity of large language models to combine concepts. So if you take, two concepts together, sometimes by putting them together, they mean something different, right? So one classical example in philosophy is pet fish, right? So if you think about, your pragmatic case of pet, it's going to probably be dog, cat. If you take your pragmatic case of fish, it's going to be, I don't know, tuna, and so on and so forth.
Yeah.
But then when you think about pet fish, then you're going to be talking about, those, goldfish, yeah, exactly, and things like that, right? So in this case, we have a combination of two concepts that generates a kind of different conceptual understanding, right? And we were interested with these colleagues at finding out whether um, these large language models can also do that. So we came up with a benchmark for tapping into that and measuring the capacity of models to do that. Not only with everyday uh, combined concepts like pet fish, but also with like invented concepts or concepts that are unlike or refer to ways of in which the world might be that are not the actual one, and to see, well, is the model going to be able to figure out what the combined meaning is, given that the parts the contributions that the parts make, and the background knowledge that is required to make sense of that, right? So if you think about, again, pet fish, you need lots of background knowledge to figure out, well, I'm probably meaning goldfish and not tuna, or not cats, right? Or anything, or catfish, or anything like that, right? So you require lots of knowledge about, practices and things that are typical and not typical, and so on and so forth.
I guess it needs like that background knowledge is kind of a sense of culture as well, in terms of sort of
Exactly. Yeah.
what's appear in one place isn't in others and things like that. I can imagine it's not an easy issue to figure out. It actually kind of links a little bit to, well, I think it could potentially link to one of the questions from our previous New Voices in AI, relating to artificial general intelligence. And I can kind of imagine that some of your work could potentially help in unpicking what is a generally intelligent AI kind of. But so our previous New Voice in AI, Chris Emizui, asked about so we often have these kind of media where we see super advanced robots, and we're not talking about Terminator very specifically, that kind of thing, but kind of working alongside robots with these kind of general intelligence. And his question was sort of in the next 20 years or so, at our kind of current rate of progress, do you think that we might be able to reach that kind of level? And what are kind of your thoughts on that in general?
Right. So, I mean, my first thought is that it's very difficult to make predictions in this area, right? So, if you look at the history of AI, there were lots of very optimistic predictions already. You know, in the 50s and 60s, people thought, well, in 10 years' time or even fewer years, we're going to be able to already have an artificial general intelligence system. And of course, that didn't pan out. So let's say there were lots of wrong predictions in the past in the field, and we still see some of that going on today, right? So I'm always a bit wary of making predictions. One thing, though, that I can say is that I think we are still quite far from understanding what is needed for general intelligence. So I think we have very good or quite good grasp on how to solve some tasks, especially tasks that either require just, relatively simple reasoning over a limited amount of information, using, good old-fashioned AI or symbolic AI, and we have a good grasp on how to solve pattern recognition tasks, like object recognition and language translation and stuff like that, for which you use the deep learning or the deep networks, right? However, is that any of that going to be sufficient for general intelligence? I don't think so, right? I think they both give us part of the story of the kinds of capacities that are needed for intelligence, but it's not the full story. So we may need something fundamentally new, which might be novel ways of trying to combine the two, but might also be completely novel kinds of architectures and learning regimes. I think we just don't know. What I'm more skeptical about is whether what we have right now, is going to be enough. Perhaps by just, increasing scale and building bigger and bigger models. I think there is still quite some progress that can be done by, making tweaks and perhaps changing some features of some architectures and increasing the size of these systems. But I do think we may need something quite novel
Yeah.
in order to get to artificial general intelligence, and we don't know yet what that thing might be. So yeah, so I mean, 20 years time seems, I think, too short for us to make that much progress. So I would be surprised if we got there in 20 years time. But again, I don't want to make any clear predictions. Just not
Yeah.
to repeat the mistakes that have been done in the past in the field.
Yeah, I feel like I could ask, when do you think you would get there? But I feel like you say, there's no good answer to that question.
Yeah, exactly. I mean, we just don't know, right? And it's like there are lots of things that we don't even know that we don't know, right? The
Yeah.
unknown unknowns.
Exactly.
So it's very difficult to, make predictions and try to understand where the field should go, given the, amount of ignorance that we are still in, right? So yeah, as you said, it's very tricky, right, to make those predictions.
Yeah. So penultimate question. is what would you like to ask the next interviewee in the series?
Right. So in general, right? So I don't know who that will
Literally
be.
anything.
I see. I see. So perhaps I would ask them, how do they see the relationships between the existing approaches to AI, whether, I mean, and here I'm talking especially about, the old-fashioned symbolic AI, neural networks, and embodied robotics, um, like people like Rodney Brooks have worked on and have been working on. And I would be curious to have some opinions on whether they are completely independent approaches that are just competitors that can't really be related to each other, or whether they can be brought together in ways that might be promising.
I think it's going to be, I always say this, but it's always really, really interesting questions that people pose for the next person. As always, I'm going to be very, very intrigued to see how people think about that, because yeah, that's definitely an
Right.
interesting one. And very finally, where can we find out more about your work, online, otherwise?
Right. So I have a website. So my research is all there. Also the conference presentations or public philosophy initiatives that I participate on. So if you just Google my name, you can find it online, with also links to papers and things like that.
Brilliant. Um, Cool. As always, we will have the links to that as well on the website. And yeah, thank you so much for joining us today. As always, really fascinating discussions. I'm going to be thinking about basic concepts and to actually understand anything.
It was a pleasure. Yeah, it was great talking
Uh,
to you.
And finally, thank you for joining us for this episode. If you would like to find out more about the series or anything mentioned here, do join us on AIhub.org. And until next time, goodbye for now.